Hello, folks. Oop, 1 second. Let me fix a thing. There we go. Hello, welcome to the stream. Welcome to Advent of Code 2024, Day 12, Part 2. Because those of you who were tuned in a couple of hours ago, I was on the stream with Rendell, and we were doing our regular Thursday podcast thing that we do, and we thought we'd have a look at Part 1, and it was good fun. And so now we're going to do Part 2, and I haven't looked at Part 2 yet. I don't know what's waiting in store and lurking for that, but I thought it would be fun to swing by and let you folks take a look. And right, let me bring up a web browser. There we go, that's a web browser. And so, Advent of Code 2024, Day 12. So, for Part 1, we had basically you got to find fences around regions and all that kind of stuff. All right. Yeah, so we got all that. I got the answer to that one. All right, so Danish licorice. Is this Danish? I thought penguin was Norwegian. Let's have a look. Danish, Norwegian, and Swedish. It's one of those things that's like we're going to put the ingredients on the back. Bought a backpack vacuum. You're an elf. Can I help you with fences? Absolutely. So, under the bulk discount, instead of using the perimeter, you need to use the number of sides. Each straight section of fence counts as a side, regardless of how long it is. Hello, Jake. How you doing? I'm just looking at, just started looking at Part 2 of today's Advent of Code puzzle, and I have an idea. Here's a map that includes an E-shaped region full of type E plants. All right, now this is we're gonna do some high-tech data visualization here. Let me just switch that on. That's up, that's off, because that light goes flicker and it's bad. And white balance will kick in any second. There we go. Now, if I switch over to that one and switch that and turn studio mode off, and let me just adjust that a little. All right, now this is my thinking. So we got this region here. So we got E, 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 X, 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 E, 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 X, 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 and E, 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 E. And so the theory is, let me just grab a colored marker. Jake says it's getting harder and harder, isn't it? It's Advent of Code. It's supposed to get harder. Right, there we go. A pink one and a green one. And that'll probably do to get us up and running. Okay, so we got this E-shaped region here. Now, the number of sides, so this counts as, so the E-shaped region here has an area of 17, and it has 12 sides. So we got one side, two sides, 3 sides, 4 sides, 5 sides, 6 sides, 7 sides, 8 sides, 9 sides, 10 sides, 11 sides, 12 sides. Okay, but 12 sides also means one corner, 2 corners, 3 corners, 4 corners, 5 corners, 6 corners, 7 corners, 8 corners, 9 corners, 10 corners, 11 corners, 12 corners. So, I think welcome back, Anaroid. Yeah, we wrapped up the podcast thing earlier, and this is me coming back and having a look at part 2 that we didn't get done because we were busy having fun with part 1. So, yes, the number of now corners are much easier to count than edges, because if we can count the corners, we don't need to worry about like long runs like this one here, where we got a bunch of things in the same direction. So what I want to do here, I want to figure out, okay, so that cell has 2 perimeter sides, right? That cell has 2. That cell has 2. So how do we find a corner? Corners will have 1 or 3 of the 4 cells in the region. Yeah, I'm thinking the way to find corners is to do a scan. If you look at blocks of 4, so if you've got A, B, that's a corner. If you've got the way most others done is to walk the perimeter and monitor turns. Yeah, boring. A, B, B, B. A, B, B, A, B, A, B. There are 1, 2, 3, 4, so there'll be 1 times 2 times 4 times A. So there'll be 15. There'll be 16 combinations. 16 different cells that but then there's also the thorny question of deciding which cell owns the corner. So if you look at this little example we got up in the top left-hand corner here, we got this corner here, which could potentially be owned by here. So, the Norwegian or Danish, the Scandinavian salted licorice pastels. I was sorting out the little rubber earbuds, you know, the things that go on the rubber tips for earbuds. I was sorting out a load of those one day, and I dropped a packet of these on the desk, and it was like, suddenly there are little black squidgy things everywhere, and half of them are edible and half of them are not. So, all right, what are we thinking? We're thinking that we want to know so Backpack Vacuum says a cell is a corner, but actually, so it's not just as simple as counting the cells which are corners, because you can have cells which are more than one corner. Like this cell here has two corners, and they both belong to that cell because they don't. There's no other candidates. There's no other elements in that which could possibly be associated with that one. So yeah, some corners are more cornery than others. So this cell owns two corners, but this corner is owned by three cells. Strange poltergeist noises happen. I mean, the approach, I think, is sound. The number of edges has to be the number of corners, right? Because an edge is what you get when a corner happens. All corners are owned by four cells, but some of those cells might not be in the region. All right, let's switch back to the code and wake up the chat and see why the chat is, yeah, that should be fine. Okay, there we go. That E has 12 corners but 10 sides. No, it doesn't. The E's got 12 sides. Count with me. Side 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sides. So 12 corners. And 12 sides according to the puzzle. Did I help? Has that just has a little red light bulb lit up above your head there? Like, oh, I see. All right. So let's figure this thing out. We can... Oh, yeah, no, hang on. I know how we do it. We get every... Yeah. So we do a walk. And so what we need to do is to build like a deduplicating hash, yeah, to check which corners, well, it won't be the same cell, which corners were the same kind of coordinate. Yeah, all right. Right, let's bang out some code. So, somewhere here there is a window with a Visual Studio Code in it. There we go. All right. So let us assume a convention that when we return a... 1 second, folks. I just need to have a little look at some German railway information. Nothing to do with Advent or code, you understand? All right, we'll come back to that. So where were we? Mr. Blue says, I can save you some time, it's delayed. My partner is in Hamburg right now on a way to meet a bunch of friends and go to a bunch of concerts, and has just pinged me and went, shit, there is no service between the Hauptbahnhof and the place where she's going, so... but it's alright. They have Google and money. They'll figure it out. Okay. So, hello, Warptux. Welcome to the stream. Let's build a thing that is going to be private and static, and it is going to return... yeah, if you've got Google and money, then most things can be solved with Google and money. Private static. Now this is going to return a IEnumerable of my favorite thing, int row int col coordinate tuples, and this is going to count corners on this int this grid no, this char grid, and it is going to take an int row and is going to take an int col is what it is going to do. Okay, how do we count corners? We start with nothing. Actually, no, we don't start with nothing. So all right, if north and paper can, we got A, B, 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 B. A has 4 corners. So what we want to do is, if A has so we can probably ignore that one, that one, that one, that one, right? Yeah, the diagonals should never matter. If you were at the left B and you only selected moves that got you to A, Android says the diags do matter. Because A has 4 corners here. So we need to find this one, this one, this one, this one. So how do we find that one? We find that one by going if all right. So scratch file. So A, B. So A. Bear with me a second. We're building a truth table. Right. So that one there is A. So this one is then A. But that one is AB, and that one is BA, and that one is BB. And then the second row of each one is gonna be AA, AB, BA, BB. Okay, so I think that gives us all the possible combinations, right? Those are all the possible ways that we can put A's and B's into a square. And I'm looking at A, and I want to know whether A has a corner in the top leftist bit of it. Yeah, no, I think that's good. I think that's maps all the perms. So that one there, does that cell contain a corner? It does if so that one is no, yes, A, B, A, yes, and no. That one there, yes. No. Yes. yes. That one there, yes, yes, no, yes. And that one there, yeah, we're checking if the center of these 4 cells is a corner. Yes, yes, no. Okay, there is a really, really entertainingly donkey way of doing this, which is that we treat those 4 cells as 4 bits. So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, and then that one becomes 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, and 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 1. All right, so those are our inputs. And basically what I'm doing here is I'm saying for each cell is the coordinate equal to the top left. So we take a block of 4, we build up a map of which ones are equal to the cell in the top. Ooh. That's gonna carve out an entire... a quick sentence to explain the problem today. Yeah, I mean, take a look on the Advent of Code thing. The problems are all public. So we've got maps made out of regions. Each region is character coded. Part 1, we had to calculate the perimeter of each coded section and multiply the perimeter by the area. And question part 2, what we need to do is to find the number of edges. And we have concluded that the number of edges is equal to the number of corners. So now what we got to do is write a thing to find all the corners in a map. And okay, right, no, more interesting. It's not that particular set of permutations. What we're going to do is we're going to build a map that the truth table is what is the same as the top left. So that one there is 1, 1, 1, 1 is a no. This next one here is 1, 1, 1, 0, and that is yes, it contains a corner. That one is 1, 1, 0, 1, and yes, it contains a corner. That one is 1, 1, 0, 0, and no, it does not. This one is 1, 0, 1, 1, and yes, it contains a corner. The next one is 1, 0, 1, 0, and no, it does not. The next one is 1, 0, 0, 1, and yes, it contains a corner. The next one is 1, 0, 0, 0, and yes, it contains a corner. The next one here, so this is what is equal to the top left, is what we're looking at. So I think Magnus might be on the right track, but I just want to work through the logic and then reduce the duplicates in the truth table. And so this one then is 1, 0, 0, 0, is yes. The next one is 1, 0, 0, 1 is a yes. The next one is 1, 0, 1, 0 is a no. The next one is 1, 0, 1, 1 is a yes. And then the bottom block here is 1, 1, 0, 0 is a no. 1, 1, 0, 1 is a yes. 1, 1, 1, 0 is a yes. And 1111 is a no. Okay, so that's our truth table. And so what I'm looking for, I mean, one, it would be trivially easy to just put this into a like a lookup thing. And if we want it to be really evil, we can, yeah, so we've got duplication. The reason we've got duplication is because like ABBB is the same pattern as BAAA. Because what with the truth table here is comparing the top left cell to the rest of the cells. Are they equal, yes or no? So we can eliminate some duplication on that. So what I can do is let's sort those lines ascending. That'll put the pairs together. All right. So that's a duplicate, 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 that's a duplicate. The first chunk doesn't matter because the first cell is always going to be whatever the first cell is, right? So that comes out. And so what we're looking at is, so now those are duplicates. And those are duplicates. Okay. Yeah, I think Martin, so Martin, I think you're on the same approach, but approaching it by a slightly different thing, adding them all up. So what I'm looking at now is yes, yes, no, yes, no, yes, yes, no. Whether there is any obvious pattern to this. And there is, but no, is there? So it's not the number of bits. One for the region, 0 for another region. So that adds to that, adds to that, adds to that, adds to that, adds to that. So 0 plus 1. Is it cheating to look up edge traversal algorithms on Wiki? Yes. I don't want to look up the solution. I want to figure it out. That's the fun. The only time I think I've ever had to look anything up on Advent of Code was to look up something called an ELE parser, because we had a thing that parsing expression grammars couldn't do because they're not, they can't do the right kind of look aheads or something a couple of years ago. So we can, okay, so we can actually just donkey this out completely because this is an 8-bit number. And so we've got yes, yes, and no, and yes, and no, and yes, and yes, and no, which means that that number there effectively gives us our map. So, right, let's crunch some code here. So what I want to do is I want to say, there's our program.cs. So this is my count corners method there. Is that readable on? Yeah, that looks all right to me. So what I want to do is, we've got bits 1, 2, 3, 4, right? So and I'm going to start row and column at -1. Because I think you have to. Because that way you get the same algorithm applied to everything you got. So values are so what do we got? We're going to build a little set of 4 things here. So we've got the northwest equals grid is greater than or equal to 0. Sorry, row is greater than or equal to 0. And col is greater than or equal to 0. Then it is grid row col. Otherwise, it is 0. Var, so that's the northwest one. Then we've got northeast equals row is greater than or equal to a 0 and column is little twiddling the bits. One up, one down, one left, one right. So row greater than equals 0 and column greater than equals 0. Crap am I trying to do? Right, northeast means we are looking for the top right cell in a block of 4 cells because we got to count the corners, which are actually off the edges of the grid, right? So that's the fun part. And I seriously wonder if we're better off just padding the entire grid. Sling a row of zeros around the edge of it. Because this bounce checking is real tedious real quick. Or I just sling an extension method on grid that was never going to blow up. Yeah, that'll do. Private static. Now that's going to be int because that's going to be the regions. So private static int at this int grid int row int col. And so what this is going to do is if row is less than 0, return -1. If col is less than 0, return -1. If row is greater than grid.length, row is greater than or equal to grid.length, yep, then we are going to return -1. If col is greater than or equal to grid row.length, return -1. Otherwise, return grid row col. Cool. Okay, so now we can say var northeast equals grid at row -1. So this is row col. Yeah, that's fine because that's now bulletproof. Var northwest equals grid dot at row col +1. Var south hang on, northwest is that one, northeast is that one. Southwest equals grid dot at row +1 col, and var southeast represent row +1 col +1. And then var bits equals, and so this is going to be an array of northwest equals northeast, northwest equals southwest, northwest equals southeast. And that should target type that to Okay. So that'll give us our bits. And we could just do, I mean, let me this is a very, very kind of verbose way of doing it. But what we can do now is we can, actually, if I make that a tuple of bools, then we can return bits switch. And I'll drop that in here. And if I make those 1 or 0, I think we can do a switch expression on here. Yes, we can. So that's not 1, not 1, naught is false, and not 1, 1 is true. But because switch expressions in .NET have a default fall through, that's true. We only need to worry about the nose. We've already got that one, so if it's 1, naught, naught is false, and 1, 1, 1 is false, and anything else returns true. All right. So private static bool has corner at this int bing bing grid int row int col. Okay. Let's check my logic. We got 3 no's in there. 010, 100, 111. 010, 100, 111. Cool. All right. So now what I want to do is count corners. I'm going to say for var so we're going to do 4 overlapping blocks. So if grid dot has corner at row -1, col -1, yield return row -1, col -1. If grid dot has corner at are we going to start at -1, or we're just going to crank the whole thing? Okay, so that will crunch through and give us is this checking only for bottom right corners? No, because what it's gonna do is look at. You'll see. You'll see. I think. So then what I'm going to do is I got this count corners method, but that's actually not called count corners. It's called find corners. And so what I can do now is that's part one is done and nice, and we like that. Actually, this can be regions to perimeters dot sum, and a function is going to take a key value pair, is going to go to pair dot value times areas pair dot key. Why is line 53 different from other lines? Because I can't type. Thank you, good spot. Then for row equals 0, row is less than regions, I can just crib this because we've got that loop in there already. It's become line 51 now, sorry. Yeah, no, I think we're good. So what I'm going to do now is I'm going to create a dictionary of int and list of int. Yield return should be the color scheme is beautiful. The color scheme is cool. I think this one is Cyberpunk 77. 2077 it's called. Cyberpunk 2077. I love the whole kind of synthwave aesthetic. Like blue and purple, and my desktop wallpaper is that, and I just like the vibe. The first line in Find Corners is thank you. Yes, that was what I was going to do originally, but I messed that up. So what I'm going to do now is I'm going to say row -1 and col equals -1. And we are going to say we need to return multiple things. Crikey, this is gnarly. Okay, so let's consider the scenario where we've got A, B, C, D. All right, does that contain a corner? Yes. Are we gonna find it when we look for A? Yes. Are we gonna find it when we look for B? Yes. Because that example, A, B, and C, and D, that one corner needs to increment every single one of its properties. Whereas if we have, so something like that, so in that scenario, no, I think this is completely on the wrong track. All right, so if we have a scenario that looks like this, for example, when we look at that one there, that cell there, that is going to say, does this have a corner? And the answer is going to come back yes. Because there is a corner there, but it doesn't belong to B. It doesn't belong to the region. So it shouldn't count towards the number of edges that B has. So I think I'm on completely the wrong track, and everything I've just done is probably a pointless waste of time. We need to look in all four directions. Boy. All right. No, hang on. This might be right. Because that's going to give us our let's crank some code. I'm possibly overthinking this or possibly underthinking this. So let's pull out the region we're looking at. Regions, row and column. Let's make that grid at method public. Yep, that should be regions at row and column. Corners.try add regions, and new should be target typed, so that should be fine. And then corners region dot add range grid dot find corners should be public. local. That should be regions dot find corners. Okay. So then let's go for each var region in regions. Console dot right dollar bang bang. Actually, that should just be corners.keys. I can do that already. That will work. All right. Yeah, that's that. That closes that out. Hello, Marianne Ivanov. Where are you from? Complicated question. I live in London. London has been home for the last 20 years. Before that, it gets complex. All right, so we got scratch.text is little. So let's run this through scratch.text and see if it even runs, let alone does the right thing. Terminal's there. Actually, you know what? Yeah. All right. So let's reinstate the map of our regions. First of all, let's make that distinct. Okay, well that's clearly and utterly boneheadedly wrong because you can't have a region with one corner. Let me reinstate that map. Hey Stoney, how's it going? Right, let's see how badly I've screwed this up. Yeah. All right. All right. All right. All right. All right. So let's just filter out that -1 because that's clearly junk. Okay. So actually, you know what fun trick I like to do is this. Yeah. Okay. Let's turn Scratch into something really tiny. So Scratch is just literally going to contain A. All right. .NET run that. It's found one region, and it says that one region has one corner. At 0, 0. Now that region does have a corner at 0, 0. It's not the one we want. Or rather, it's not all the one. It's the truth, but it's not the whole truth. So my find corners method, that ain't doing the right thing. Yeah, stringpad is a standard .NET thing. I don't have any libraries for that. So this is going to dump out all of our corner checks. And if I put a $sign in there, it'll actually print out the values. And let's just make that a little... That's weird. Where's -1, -1, -1, -1 coming from? So let me just comment those out for a second. Run that. Okay. That top left, so that's wrong. So let's check in at row column. So that's our entire grid. We got one thing. We got one single number 4 sitting by itself. That has been correctly assigned to be in region 1. Let me just change this thing to be a... So it's going to return zeros. Those top 2 are incorrect. Okay, right, let's think this through. Break it down one step at a time. And we are trying to if grid has corner at row column, yield return row column. So let's do a console.writeLine row column in there. Okay. So -1, -1. SE equals grid.at. So that grid at there should be returning a value. Right? Because we got -1, -1. But then we're feeding -1, -1 into northeast, northwest, northeast, southwest, southeast. I think that's just, okay, good, right. That's fine. Okay, so we're getting the right things out. So now we can see that this is the thing we're interested in, and we're looking at the 4 corners of that cell number 1 to see if any of them contain a thing. So northwest equals northeast. So maybe you are missing the corners looking outside. No, I don't think so. Yep. Yep. Let's check that because we're not using -1 anymore. All right, let me just comment that out and comment that out and comment that out. So that only finds Do you know which corner it's counting? Is the top left one or the bottom right one? It should be the bottom right one. So for each... Yeah, but what it should be doing is it should be pointing the region of interest to 4 different elements in the grid. And for each one, all right, so this one is looking at -1, -1, and it's saying that one there. Okay. -1, -1. So starting from the kind of off to the top, off to the left, yes, it finds a corner. Yep. This is just finding a corner all the time, isn't it? Yeah. So that question is exactly the scenario that I just mocked up with this thing here. It's a corner when looking from B and C, but not when looking from A. But the problem at the moment is it seems to be simultaneously counting way too many corners and not nearly enough. It's a 180-degree corner for B. I like that. I don't think it'll get us any points, but I do like it. Right. Okay. So that has found the correct number of corners. Because there's a corner at 0, 0, which is the bottom right-hand corner of our one grid cell. There's a corner at 0, -1. There's a corner at, -1, 0, 0, and a corner at -1, -1. So that should have returned 4. All right, so I'm just going to take out a bunch of that diagnostic debugging from the other method here. So we'll kill that, we'll kill that, we'll kill that, we'll kill that. And that is correct. That's what I was expecting. If we stick a distinct on that, it should... No. What? Hang on a second. Hang on a second. Yeah. It's finding the corners, but it's attaching them to the wrong region. So Martin says it was a fun one once you realize that sides and corners are equal. Well, I realized that before I started part 2, and I'm not making any real progress with it. Right. I'm just going to try brute forcing something. So that's row -1, column -1. Row -1, alt -1. Yeah, 8 points including diagonals. I think that's the problem. Yeah. Hmm. Hmm. Right, let me think. Let me think. If we are looking at a cell, right, I'm going to break this down into some ridiculously granular code. Okay, so actually, I'm going to push this to GitHub. Then I'm going to break it down into some ridiculously granular code. Git add dot git commit minus m 2012 stuck. Right. So, public static bool has top left corner. This int dink grid int row int col. So a cell has the top left corner if row is 0 or column is 0, then return true. If under what other circumstances does a cell have the top left corner? So if row is greater than 1 and grid so a cell has a top left corner if both its upstairs and its left-hand neighbor are different to what it is. So if grid.at row column is not equal so if the one above it is the same, it can't have a top left corner. And if the one to the left of it is the same, it can't have a top left corner. Okay. So now find corners, I'm going to scrub all that. I'm going to say, yeah. This is the whole thing where we need to return the distinct count of the corners, right? Because we may have corners that belong to more than one cell. Right. Scrub all that. Or at least comment it out. I don't think that was helping us very much. So let's go really, really old school on this. Really kind of break it down dumb. And if what do we mean by a corner belonging to a cell? So you think about a scenario like this one here. So we've got a corner there. If I space this out and stick a return in it, all right. So we've got this corner in here, which belongs to C and it belongs to D because it has to count towards both of C and D's corner counts. It doesn't belong to B. And so you can have a point where a corner belongs to a region. We'll get there. Give me one sec, folks. Yeah. Cornerness can only be considered per region. Yeah. They do all have corners at E. Yeah. So the example there would be this one. Wouldn't your has top left fail for the B in the middle of that? No? I mean, let's see. So if I put that into my scratch.txt, there we go. Back in 1 sec, folks. Sorry, I'm juggling a whole bunch of things here. Right. Okay, int does not contain fine corners. Let's take out the thing that does fine corners. Folks, I'm afraid I'm going to have to drop off. Something has come up that I have to go and deal with. We are going to come back to this at some future point. So, Luca Clock has just turned out and said, woohoo, I caught a live one. I only just caught it, I'm afraid. Yeah, I got some stuff I need to go and deal with, which has just come up. So, folks, thank you for tuning in. I'm going to leave this exactly where it is, and we'll come back and take another look at it when I've had a chance to think it over a little bit. You folks look after each other. Take it easy. I'll catch you later. Bye-bye.